Example 3 says, calculate the molar heat of complete combustion for ethane, which is C2H6. So for any complete combustion, regardless of what the fuel is, in this case, our fuel is ethane, when it reacts with oxygen gas, the products will always be carbon dioxide gas and water vapor. And this question is asking to use both methods that we've learned so far. On the left-hand side, we're asked to use the bond energies method. And on the right, we are using standard enthalpy of formation, so from the previous lesson. The first thing we need to do is balance the reaction. So when you balance the reaction, you will see that there are 7/2 oxygens, 1 ethane molecule, 2 carbon dioxide molecules, and 3 water vapor molecules. Okay, so for the bond energies method, remember our equation is delta HR is equal to sum of the energy of bonds broken subtracting sum of the energy of bonds formed. With this method, we need to draw out our Lewis structures. Okay, so for ethane, this is what your Lewis structure looks like. Typically for your hydrocarbons, your carbons are always centrally located, and your H's are going to be the attachments on your carbon atoms. There is also 7/2 oxygen molecules. We've already learned how to draw the oxygen molecule in class, as well as carbon dioxide. That looks like this. There's 2 of these, and 3 water molecules. Okay, so now we can see and visualize the bonds that need to be formed and the bonds that need to be broken. So taking my delta HR, first I need to add up all of the energy bonds that are broken. So I know that there are 1, 2, 3, 4, 5, 6. So 6 moles of my CH bonds that are broken. So 413 kilojoules per mole. Plus, there are 7/2 double bonded oxygen bonds. So 7/2 moles times 495 kilojoules per mole. Plus, I'm missing one more that I actually forgot about. There is a bond between the 2 carbons on your ethane. So there's 1 mole of that, and the bond energy is 347 kilojoules per mole. Okay, so these are my bonds that are broken. And I'm going to color coordinate it so that you can better visualize which one is associated with which. And now I'm going to do my bonds formed. So if I'm looking at my carbon dioxide, there are 2 double bonded carbon-oxygen bonds in one CO2 molecule, but there are 2 CO2 molecules. So that gives me a total of 4 double bonded carbon to oxygens. So we have a total of 4 bonds of double bonded to carbon and oxygen, 799 kilojoules per mole, plus for my water molecule, H to O bond, there's 2 of them, so 2 moles. But there are 3 water molecules, so we multiply that by 3 times 2. And the bond energy is 467 kilojoules per mole. Okay. So this over here in the purple and green are the bonds formed. So now you will input all of these into the calculator. 4,557.5 kilojoules minus 5,908 kilojoules, and that gives you a negative 1,440.5 kilojoules, which we will round to negative 1,441 kilojoules.